More example and one more concept today based on this. And this is for functions that are better defined in terms of x. So we're going to integrate in respect to x. This might be the first time you've ever done this. I'm not sure if you maybe in pre-calc somewhere. So yeah, this is on page 4. Basically, okay, I'm going to go back to this example we had before, but I'll look at this one up here for a minute. It's similar to the one we did last time, where if we did top minus bottom, we could, but the bottom one changes. So we'd have two different intervals, which is fine, it would work. But what we can also do is solve them for x. So they were solved for y, in this problem they solved it for x. X equals y plus 4, and then, sorry, see that, x equals y to the 3 halves. So they solve them for x. And then, what you can do, instead of top minus bottom, they're in terms of x. Sorry, they're solved for x in terms of y. What you can do is the right function minus the left function. So it just changes the independent and dependent variable, the x and the y in there. And so instead of basically this being our dependent axis, okay, for x and y, it changes it to this is. And so you got to kind of think of it as being like rotated a little bit. So you're looking at it as this is the dependent one. Like it's x, but now it's like that. It's treated as like the y one. So what we can do though, looking at it normally like this, we can now do right minus left. And you can say this one, the right and the left, there's no change. So why this one could be slightly easier in terms of x is because it's just one integral. We don't want to split it up into two. So that's what I say here. This was previous. So if our interval is an x value from a to b, top minus bottom. If we've solved it for x, it's in terms of y. So now we go on our interval y values. So it'd be from here c up to here d, and we do right minus left. So very similar to before. It's just instead of top minus bottom, right minus left. Instead of it solved for y, it'll be solved for x. Let's try one. So this is the one from the previous page. It's the exact same one. So I said we're going to repeat this, but do it in terms of solve for x in terms of y. Integrate with respect to y. So let me draw a quick picture of this one. It's the same one from last time, where it's these two functions in the x-axis. So the first thing I did was I drew like the x-axis. Okay, then square root of x, just something like that. And then x minus 2. A line like that. And so it's bounded by the square root of x function, the x-axis, the purple there, and then x minus 2. And so is that region in between there. Okay, so it's top minus bottom. We had to split it up because the bottom function was different. Okay, the bottom function was different. What we're going to do now is we're going to have it in terms of y. We go right minus left. The right function is always the blue line. The left function is always the red curve. We only need one integral. That's why this one can be nice at times. Okay. Okay, so step 1 in this process I already did. I made a sketch. Step 2 that I always do is find our interval. What we're going to integrate between. Now, I haven't yet solved them. I need x. I'm going to solve for x in terms of y. So let me actually do that, and then I can do step 2. But it's kind of at the same time. So I need to solve them for x. So the first one, I'm going to square both sides, and it'll be y squared equals x. Square root of x squared is just x. This one here, I need to solve for x, so I'll add 2. And so we'll have y plus 2 equals x. Okay, And that helps us for step 2 and step 3. So now I need to know where to integrate between. So I need the low value, which I already have, because we're at the x-axis, that's the lowest y value. So we're going right minus left, so I need, remember when it's top minus bottom, we needed the x interval. When it's right minus left, we need the y interval. So the lowest y value is just 0, x-axis. I need this top y value, and just as before, to find where these intersect, to find that y value, I set it equal. So I'm going to set y squared equal to y plus 2. This sets up a factoring one. I'll subtract y, I'll subtract 2. And then I can factor the trinomial. Multiply at -2, so -2, +1. And those add to get -1. -1y. So I get 2, y equals 2, and y equals -1. Okay, so the one for our purposes that we need is the 2. That would be the positive one there. Good. So I made a little sketch. It's right minus left. I only have one integral I'm going to need. I found the intersection, so now I know it's 0 to 2. And step 3 is just to integrate. Again, the right function is always the blue line. The left function is always on this interval. It's always blue line on the right, left curve in red on the left. And so it's 0 to 2, low to high still. Right minus left. So the blue line, and I need it in terms of y. So the line is going to be y plus 2. Minus, and the left is always the right curve, in terms of y, is y squared. And this will be dy, since the variables are y. Let's do this one. So again, some of them I will make sure on quiz or test say solve by hand or evaluate on your calculator. Let's do this one. F of y, the antiderivative is for y, it's going to be y squared over 2, power rule. Then I got a 2y, and then a minus y cubed over 3. And then we're just going to do f of 2 minus f of 0. I'm going to just fill in the 0, 0, 0, 0 will just be 0. So really it's just going to be evaluating f of 2. So f of 2, when I plug it in, 2 squared is 4. 4 divided by 2 is 2. 2 here would be 4. And then 2 here would be 2 cubed, 8 over 3. Okay, and you just combine minus 0. You combine those and you get 10/3, or 3.3 repeating, which you should look back on the last page. It's exactly what we got when we did the same example here. It was in terms of x. Same exact answer. All right. So we've seen top minus bottom, now we've seen right minus left. Be careful to set up the integrals correctly and the intervals. Make sure it's top and bottom the entire way. If not, you got to break it up.